Hello everyone, and welcome to our Line 45 general presentation. In this presentation, we will be giving a brief introduction of our client. We will also talk about the process of working through our AMRE project's deliverables. Let us get started by doing some brief introductions. I will start. Hello again everyone, my name is Kyle Rossi. I'm a computer science major at the College of Worcester in the class of 2023. My pronouns are he, him, his.
Hello everyone, my name is Young-Seok Tommy Lee. I'm a computer science major at the College of Worcester in the class of 2023, and my pronouns are he, him, his.
And hi, my name is Chinwe Ibebu, and I am a computer science major at Ashesi University in the class of 2023, and my pronouns are she, her, hers.
Now that we've introduced ourselves, let's take a look at our client, Line 45. Line 45 is a small, fully remote software development company which offers data collection, analysis, and visualization services. It serves companies and nonprofit firms in the oil and gas, conservation, and energy industries. Our points of contact at Line 45 were Douglas Code, Senior Software Developer, and Alexander Code, who is the founder and current Managing Director. We have met with our client on a near weekly basis, with each meeting serving to provide clarification and direction on the project for the team.
As a team, our primary concern was focused on an application called BENSYS, an oil and natural gas asset management system which functions as a web application. Our task at AMRE was to build out an automated testing suite for this application with a focus on the back end of it, which is built on an interface called GraphQL API. The aim was to ensure that updates can be made to the application with greater certainty that existing functionality will not be broken for the users.
Before we move on to the details of our work, we will be giving you a high-level overview of our project. All web applications such as google.com, outlook.com are divided into three parts. The front end, which is what you see, the back end, which processes the website's data, and the database, which stores the website's data. The tools which are used to develop these three parts are jointly referred to as a web stack. The photo on the left shows the web stack for the BENSYS application.
As mentioned on the previous slide, our focus for AMRE is testing the backend of the application, specifically the GraphQL API. In simpler terms, the API is the part of the web stack which allows the front end to communicate with the backend. The interaction with the API is carried out using queries, which fetch data, and mutations, which change data. For each test, a request with a query mutation is sent to the server and a response is returned. Our job then is to test that data returned matches the data that is expected from the database. For this process, we used mock data to test the API, not the data actually used by the system.
And so here we have our project timeline, which was divided into 4 phases. At the end of each phase, we were expected to send a deliverable to our client. Phases 1 to 3 were core for the project, while phase 4 was to be worked on given the remaining time. A more detailed timeline, which includes task delegation, will be presented in the following slide.
As shown in the table, phases 1 and 2 were completed in weeks 1 and 2 respectively, while phase 3 was completed in week 7. Our last 2 weeks at AMRE were focused on finishing phase 3, starting phase 4, and completing the AMRE final deliverables. Although we divided our tasks accordingly, we also helped each other out when any of us ran into issues. This would either be done at our daily meetings with our advisors or in meetings separately when needed.
Additionally, we used a shared document called the task tractor, which is effectively a to-do list, to make sure we were all on the same page regarding the work we did each day. We created many other documents to help us document our progress, such as the deliverable number 3 tracker, and these files made working on the AMRE final deliverables a lot easier.
Our first deliverable focused on researching software testing, its types, use cases, and ultimate goals, which were expected to summarize for a client in a 2-page document. As a team, we decided on 3 types of automated software testing methods. First, unit testing, second, integration testing, and lastly, smoke testing. Since there were 3 members in our group, we implemented a divide and conquer approach, where each member would be tasked with researching and writing about his or her respective testing method.
Additionally, for this deliverable, we were told to write with a specific target audience in mind, software developers who have no prior knowledge of software testing. We also included a reference page which showed where we got our information from, as well as gave our hypothetical audiences resources to look into if they want to know more about software testing.
Unlike our first deliverable, we took a more collaborative approach to completing the second deliverable since there was a lot more to cover. This deliverable was mainly focused on the different testing frameworks available that could be used to test the BENSYS API, which was written in Python 3. Each of us researched and considered many different frameworks, all noted under the frameworks considered. This list was eventually narrowed down to PyTest, unit test, and doc test, based on ease of use, available features, community support, and scalability. Similar to our first deliverable, we were expected to deliver a 2-page report in detail outlining the selected frameworks.
From our research, we found that PyTest was the most appropriate framework for this project. PyTest's ease of test implementation, special features, robust documentation, lack of disadvantages, and its large dedicated community made it a clear winner among the 3 frameworks. Furthermore, our client had already used PyTest as a framework before they switched to the GraphQL API. This meant that we could also benefit from their expertise. Our target audience was the same as the previous deliverable, software developers who had no prior knowledge of software testing. We included a reference page, again, just like deliverable 1, that featured the resources that we used.
Deliverable 3 was a big jump from our previous 2 deliverables in that we delved deeper into the API itself and actually started writing code. Our main deliverable for this phase was to create an integration testing suite for the Bensys GraphQL API. There were 43 queries, 7 query parameters, and 36 mutations to test. The task for this deliverable were to increase the robustness of increasing tests, create tests for the queries unaddressed by line 45, create tests for all query parameters and mutations, and reformat code to reduce code repetition. Afterwards, we were expected to commit and push our work to the line 45 Git repository, which we had access to.
Similar to our first deliverable, we used the divide and conquer approach again to tackle the queries, query parameters, and mutations. Whenever we were running into issues, we would bring those issues up with our meeting with our advisors, which were usually at 1 p.m. every weekday, barring any conflicts in our schedules, of course. If this issue could not be solved with feedback from our group members or our advisors, only then would we reach out to our client. In most cases, the issues that we brought up with our client occurred due to issues on either their codebase or the server.
And so the pie chart on the left shows the proportion of queries that were disregarded, wrote from scratch, or improved on respectively. The majority of the query tests were provided by the Line 45 team, and we used them as the basis for writing the other 15 tests from scratch. The 2 queries were disregarded due to system admin permissions, and we were explicitly told by our client that there was no need to work on these queries.
The pie chart on the right, on the other hand, shows the proportion of mutations that were disregarded, either due to issues with the code base or needing system admin permissions, versus the mutations that we wrote as a team. All mutation tests were coded from scratch, given as they were not previously attempted by the team at line 45, unlike with the queries.
The table shown showcases the results from using the coverage.py plugin, which uses the Python standard library to determine which lines of code are executed. The coverage tests were run before and after we merge all of our tests together through Git. The statements section represents the number of statements present in the code, and the misses represent the number of statements that have not yet been executed. The percentages in the coverage column were calculated by dividing the number of misses by the number of statements and subtracting that value from 1.
Before AMRE began, code coverage started off at 68%. After adding the core tests that our AMRE team created, code coverage went to 71% and then to 73%, after adding tests for the query parameters and adding more depth to the already existing tests. Finally, after adding in all the mutation tests, code coverage rose up to 87%.
With all of our deliverables discussed, we want to close this presentation with a reflection of what each of us learned during our AMRE project. I really learned to love working in a group thanks to AMRE, something that I did not enjoy, especially in high school. Being able to effectively communicate with teammates and adapt to any situation will be infinitely useful throughout the rest of my life. If I were to give someone any advice, I would tell them to simply do their best work and not be held back by the fear of making mistakes.
In my case, I want to talk about how the AMRE experience has impacted me professionally. This was my first real job in programming, and throughout the process, I made a lot of mistakes and learned from them. With this experience, however, I now have a better idea of what to expect in any future internships or jobs I may have in the field of computer science, and I will now be better prepared for them.
For me, AMRE gave me the opportunity to contribute to an existing code base for a production application, and it's been a great way to see the tools that I learned in school and have applied to only small-scale projects being applied to a complex multi-layer and dependent-heavy application. And although I would have loved to work on the Worcester campus, I really enjoyed meeting people from different academic, professional, and cultural backgrounds. Thank you all very much for listening, and do have a lovely rest of your day.